Good evening, children. Welcome to One Mark Solution. Here we are going with assertion and reason, the second part of the chapter current electricity, and it is a unit 2. Chapter number 3, unit 2, current electricity. This is also one of the very important topic. So please, children, subscribe, share, and if you like it, you please like it. Now let us start with the first assertion and reason. Here, statement 1, internal resistance of a battery is drawn parallel to a battery in an electrical circuit. Internal resistance actually will be drawn along with the cell, but it is in series, not parallel to a battery. So that statement is wrong. Second statement, we will read it. Heat generated in a battery is due to internal resistance. No, not at all. It is resistance which will generate heat, but it is not due to internal resistance. So here we can say both the statement 1 and 2 is false. One thing I want to say, children, internal resistance is very important topic. Internal resistance is, what is it, depending on some factors that also you have to study. That means the distance between the electrodes, the nature and the concentration of the electrolyte, and the electrodes, of course, we can say the area of the electrode which is immersed in the electrolyte. These are the factors. Please study. Why I'm telling this? Because usually the children will make a mistake. What are the factors affecting resistance? You will write. If it is internal resistance, you have to write these all things. If it is a resistance, you can say length, area, nature of the material, and so on. So please read the question and write the answer for it. So here the answer, both the statement 1 and 2 is false. So we can say the option D. Now we can go for the second one. Statement 1. The possibility of an electric bulb fusing is higher at the time of switching on and off. We know that sometimes when we switch on, it will go off. The electric bulb will fuse, isn't it? And why it is like that? Why? Because at that instant, what will happen? The intensity effect will be producing. So that is why it can fuse very soon, on and off, fast on and off. Now, so what is it? The first statement is correct. Second statement is also correct. And it is a correct explanation for the first one. So the option A. Now let us move on to the third one. We can say the 200 watt bulb glow with more brightness than 100 watt bulb. Yes, is it so? The 200 watt bulb, that means the power will be more. 100 watt bulb, the power will be less. And the relation between the resistance and the power is P is equal to V squared by R. And then we'll go for the statement 2. A 100 bulb has more resistance than 200 watt. Why it is like that? Why? Because we can say P is equal to V squared by R. Just now I told the equation. That means power and the resistance is inversely proportional. When the resistance increases, what will happen? The power will be decreasing. Or if power is more, resistance will be less. So here we can say a 100 watt bulb has more resistance than a 200 watt bulb. No doubt. So the first statement and the second statement are true. But we can say the second statement is a correct explanation for the first one. So option A. Now we can go for the next one, fourth one. Fuse wire must have high resistance and low melting point. This all of you know that. It should have high resistance and low melting point. If it is high melting point, what will happen? We know that. What is it? When the current is passing, it won't melt. So the other devices will be damaged. So the statement is correct. Next one, the fuse is used for small current flow only. No, not at all. So the second statement is false and the first statement is true. So fuse, you should know all these things. The fuse wire, about the fuse wire, and what is the importance of the fuse wire, you should know that. All of you know that, I think. So here the answer is C, option C. Now let us move on to the fifth question. Two electric bulbs of 50 and 100 watt are given. Two bulbs are given. When connected in series, 50 watt bulb will glow more. When connected parallel, 100 will be glowing more. 100 watt bulb. we know that P is equal to V squared by R. So in these 50 and 100 watt, we know that 100 watt will be less resistance. And when it is connected in series, we know that 50 watt is having more resistance. Current will be same for 50 and 100. In series combination, all of you know that the current remains constant. So it depends on the resistance, right? So I squared RT we can say, that is the heat produced. So here we can say the 50 watt will be glowing more. Why? Because P is equal to V squared by R. But when connected in parallel, what is happening? Voltage remains constant. So the 100 watt bulb will be glowing more. So you can see the reason. In the first case, in the series case, we can say the power is directly proportional to resistance. In parallel combination, we can say P is inversely proportional to R. That is, P is equal to V squared by R. The first case, P is equal to I squared R. So that is the reason. So statement 2 is the correct explanation for the statement 1, and the option, both the statements are correct. So the option is A. Now let us move on to the 6th one. Yes, electric appliances with a metallic body, example heaters, presses, etc., have 3-pin connection. 3-pin means 2-pin anyway you have to connect. If you are connecting 2-pin, then only we'll get current. All of you know that. What is the use of the 3-pin? For earthing, for grounding, we can say. Right? That means if any more current, more voltage is coming, it will directly flows to the earth and earth will attract. That means earth will, yes, accept all the charges, ready to accept all the charges, and the device and the complete, what is it, V, right? The user also will be more safe. So for safety purpose only, we are using 3-pin connection. Now, what is the second statement? 3-pin connections reduce the heating of connecting cables. Is it so? That is why we are using it. Actually, that is also, first statement is correct. What about the second statement? Second statement is not correct. Why? Because it is not reducing the heating of connecting cables, not at all. So which is the option? Option C. The first one is absolutely correct. Now we can go for the 7th one. We can go for it. Current is passed through a metallic wire, heating it red. That means it will red hot, we can say, right? When cold water is poured on half of its portion, that means if metallic wire is a half portion, we are using cold water. Then the rest half portion becomes hotter. Why? We know that when the temperature decreases, resistance also decreasing in the case of the conductor. So here statement we can say resistance decreases due to a decrease in temperature, and so current through the wire increases. So what is answer? The second statement is absolutely correct explanation for the first statement. And this one you have to think, you have to keep in your mind, resistance decreases or increases according to the temperature only in the case of the conductors. In the case of the semiconductors, it is just reverse. That means in the case of the semiconductors, resistance increases with the decrease of the temperature, and so the resistivity also. That is just opposite of the conductors. That is also very important. So here the option is A. Both the statement are true, and the second one is the correct explanation of the first one. Let us move on to the 8th one. Leclanche cell is used when a constant supply of electric current is not required. Just think it of Leclanche cell and the Daniell cell you are comparing, isn't it? In the case of the potentiometer, compare the EMF of the cell, you are familiar with the Leclanche cell. And here we can say, if you don't want steady current, we can use Leclanche cell. Why? What is the reason? The EMF of a Leclanche cell falls. That means voltage drop will be there if we are using for a continuous purpose, isn't it? So that is why here we can say, if you want to use Leclanche cell, use it whenever we don't want the steady current. So the second statement is the correct explanation for the first statement, and both are true. So the option is A. Now we can go for the 9th question. You can see a circuit here with the 3 bulbs. If the 3 identical means everything is same, the power, everything is same, are connected in series as shown in the figure. It is connected in series. But you can see that one switch is in between. Bulb C short circuited and hence illumination of bulb A and B decreases. See that? There is a connection in between, a switch is there. On closing the switches, bulb C is short circuited. You know that it is short circuited and hence illumination of bulb and A and B decreases. No, not at all. Why? Because when current is flowing, you can use Kirchhoff's first law. Current is flowing there. If we are not switching on the switch, that means if we are opening the switch, what will happen? Equal current will be flowing. So equal illumination. When it is closing, what will happen? Some current will flow through that also. So when it reaches C, it will be reducing. And the statement, what is the reason here it is given? That reason we have to give here. But here reason is voltage on A and B decreases. No, not at all. So here we can say both the statement are false. So the option D. Now let us move on to the 10th one. Heat is generated continuously in an electric heater, but its temperature becomes constant after some time. Then we know that, isn't it? The temperature will be remains constant. That means a steady current will be flowing. Then more, temperature won't be rising. Statement 2. At the stage when heat produced in the heater is equal to the heat dissipated to its surrounding, the temperature of the heater become constant. Why it is like that? At this stage, that means at the temperature constant, heat produced in the heater, what they are giving to the surroundings also. Dissipated, they are giving to the surroundings. So what will happen? Temperature remains constant. So the statement 2 is absolutely correct explanation for the statement 1. So which is the option? Option A. Now we can go for the 11th one. That is, an electric bulb is first connected to a DC source and then to an AC source, having the same brightness in both cases. Bulb is first connected to DC and then to AC source. No way. It won't glow with the same brightness. Why? Because AC and DC is entirely different. If we are giving 200 DC source, we can say that voltage will be flowing through that bulb. But if we are using 200 voltage AC source, it won't be flowing there. We can say root 2 times. That means VRMS is equal to V0 by root 2. That voltage is flowing. So that relation you should know. The peak value of voltage, that means maximum value, V0, we can say for an AC source is root 2 times the root mean square voltage, or we can say VRMS, or we can say virtual voltage. So this is the correct explanation. Statement 2 is the correct explanation and statement 2 is true. But the first one is false. It is not having the same brightness. And you should study AC and DC. In the next, coming chapters, alternating current is there. There you can study this one, all these things. Okay. Now, once again, I'm telling, please study the concepts first of all, understand the concept first of all, then you can answer any questions. Thank you for watching. Thank you once again.